Algebra 2, Unit 3, Day 1. Okay, let's look at these notes here. In the past, we've been working with graphs of one function at a time, and now we're going to graph more than one. So when we graph more than one, we call it a system. So the first day here, we're going to look at a system of linear equations, which means we're just going to draw more than one line on a graph. So let's look at a real life example, okay, a word problem. So Nicole will rent a car for a day. Good for Nicole. She needs to drive. The rental company offers two different pricing options, option A and option B. For each pricing option, the cost in dollars depends on the miles driven, as shown below. Okay, so the miles driven, as the miles change, the cost will change. Okay, so with this red option, option A, you can see that the more miles that are driven, the higher the cost is. Meanwhile, with the blue option B here, no matter how many miles are driven, you are going to charge, or in this case, Nicole is going to be charged one price, no matter what. Okay, so let's analyze the situation and look at question A and B. So A says, if Nicole drives the rental car 75 miles, which option costs more and how much more does it cost than the other option? Okay, so let's look. Well, no matter how many miles she drives, let's look at 75 right here. And let's go, different color here. Let's go up the grid line. Okay, so let's try it again. See if I can go a little bit straighter. Not bad, not bad at all. Okay, so that's 75 miles. Let's see where it intersects option A. Option A, it intersects right there. And it looks like the cost is, what is that, 45? My eyes don't deceive me. We got $45 for option A. So A costs $45. And then B is the intersection right here. No matter how many miles they drive, B is going to cost 60 bucks. So B costs $60. Okay, so with that in mind, let's look at the question again. Which option costs more and how much more does it cost than the other option? Okay, well, that should be pretty straightforward. B costs 60 minus 45 is 15, so $15 more. Okay, so if Nicole is going to drive about 75 miles, B is going to cost her more. Okay, so that's a nice piece of information that will probably let her say, hey, rental company, I want to use option A because I'm going to drive about 75 miles. I want to save 15 bucks. Okay, B. For what number of miles driven do the two options cost the same? Okay, so we'll start with that, and then there's more to the question, but we'll start right there. All right, so let's erase work from the previous question. And now we need to look at this graph and see where the costs are the same. So when the red has the same y coordinate as the blue, well, that's where they intersect. That would be at this point right about there. Okay, that's where they intersect. So it looks like they intersect when the miles driven is 150. Okay, so at 150 miles driven, both options would cost $60. Okay, so let's answer the question. For what number of miles driven do the two options cost the same? 150 miles. Okay, so if she's going to drive 150 miles exactly, it doesn't matter which option she chooses, she's going to pay 60 bucks either way. Okay, so now it says, if Nicole drives less than this amount, which option costs less? So if she drives less than the 150, which of the two options, the blue or the red, will give her a lower bill or a lower cost? Now, hopefully you can see that as the miles decrease, the red option is lower than the blue option. Okay, the red line is below the blue line. So we would say if she drives less, A will cost less. Okay, A will cost less if she drives less than 150 miles. So 150 miles is what we call the break-even point. Okay? It doesn't matter. Option A, option B, they're the same. Okay? But if she thinks she's going to drive less, then she should be prepared to save some money with A. And if she thinks she's going to drive more, well, A will cost more, so she should choose option B. Okay. All right, so let's continue on. So it says a solution to any system is simply a point or more than one point that satisfies any equation in the system. Okay, it has to satisfy all of them. Okay, so if I put the coordinate pair 3, 4 into any system and it works for every single one, then 3, 4 is a solution. Okay? So there are actually three different types of solutions that we're going to have when we have these questions. We're going to have questions where we have a single solution. So sometimes our system will have one solution where there is one point that both lines share. Okay? We had that in the previous question. If you remember here, this point, it was a point of intersection. It was the point 150, 60. Okay? So whatever the equations were for A and for B, the point 150, 60 worked for both of those equations. It made them true. If I plugged in 150 for X and 60 for Y, okay, then it worked. So because it worked for both of them, it was a solution. So when you see one intersection, that's one solution. There could be infinitely many solutions to a system. Okay? Let's say that you have a line. This line right here is graphed. And then you solve for a second line, and it happens to be the same line again, and you draw one right on top of another. That means every single point on the line is a solution because it works for every equation in your system. So there are infinite solutions because every single point that works on one line works on the other line. Why? Because of the same line. And then finally, we will have some times when we have no intersections, which means we will have no solution. And no solution, well, when two lines don't intersect and they're in one plane, well, geometry tells us they are parallel. Okay? So the equations have the same slope. Okay? They have the same steepness, but they have different y-intercepts. Okay, notice this particular line has a y-intercept that appears to be up at 1. And then this line here has an intercept that is actually right off the graph, but it's definitely in the negatives. And so it's not the same y-intercept, but they do look like they have the same rise over run. And they do look like they're never going to intersect each other, right? So one solution, infinite solutions if it's the same line graphed twice, and then no solutions if you have two parallel lines, okay? So we're going to graph two lines, and we're going to see how many solutions they got, okay? And if they have any solutions, we're going to write what they are, okay? If there's only one solution, we'll write it, and if there's infinite, we'll say infinite solutions. Okay, so let's graph these. Now, most of you will graph this one much easier. Why? Because it's in y equals mx plus b form already. So I'm going to put red around this one to show that we're going to graph it in red. Right? Now we're going to take that plus 2, and that's the y-intercept, that's the b. So we're going to put it right on the y-axis. And now we've got a rise over run of 1 over 4. So we're going to rise 1 and run 4 for the next point. So I'm going to rise positive 1 and run 4 for the next point. Do it again, rise 1, run 4. Okay, cool beans. All right. You can do it again, 1, 2, 3, right up the edge. And you can go the other direction. You can rise negative 1 and run negative 4, and it's the same line. Okay, so we can go down 1 and left 4. Down 1 and left 4 more. We can do it one more time. 1, 2, 3, and 4 right there. Okay, so this is all one line. And this is y equals 1/4 x plus 2. This next line, we'll do this one in blue. Now, this one has a y almost all by itself. What I mean by almost all by itself, it doesn't have a coefficient. It's 1. It's positive 1y. So if I just take the minus 2x or the negative 2x and I add 2x to both sides, I could rewrite this one as y equals positive 2x. Right, and this 5 is negative, so we're going to go minus 5. Okay, so we have y equals mx plus b again, which is really cool. So let's do that again. We're going to do the y equals mx plus b. Here's my b, so we're going to go to negative 5. I'm going to put a dot there. Okay, now the rise over run is the slope. Anytime there is an integer there, feel free to put it over 1 to remind you that the rise is 2 and the run is 1. Okay, so we're rising 2 and running 1, and it's a positive slope, so we're going up to the right. Okay, so we're rising 2, running 1, so we're going to go right there. Okay, rise 2, run 1, rise 2, run 1, rise 2, run 1. Oh, we got our winner right there. We'll do a couple more. Okay, so as long as you get their intersection, that's all you need for the solution. Okay. So that's y equals 2x minus 5. And lo and behold, there is one solution to this system. Okay, how do I know? Because there is an intersection at one point. Where is that? Well, take a look. 1, 2, 3, 4 to the right, and 1, 2, 3 up. So it looks like the solution is at 4, 3. But I'm going to be smart, and I'm going to check my answer. All right, so I'm going to take my blue graph, and I'm going to substitute 4 in for x, and 3 in for y, and see if it works. Okay, negative 2 times 4 is negative 8, plus 3 equals negative 5. So guess what? Negative 5 equals negative 5. That tells me it is on the blue line. Okay, and I'm going to check my answer with the red line. So y equals, so I'm going to substitute 3 for y again. 1/4 times x. X is 4 plus 2. Well, 1/4 times 4 is 1 plus 2. So 3 equals 1 plus 2, 3 equals 3. That one works too. So I have checked my answer. There's no way it's wrong. That point, 4 comma 3, is a solution to my system of linear equations. Right? Let's go down to question number 2. All right, so once again, whenever I see a y equals mx plus b, I just like to do that first because it's easier. Okay, I look at my b. My b is a minus 1, so negative 1 is where I'm putting my first point, my little dot. Now, this one's negative. All right, I'm going to be rising 1, running 4, and the line has to be falling to the right because it's a negative slope. So rising of 1 and running of 4, making sure the line is falling to the right. So we can rise positive 1 and we can run negative 4, okay, which would be here. So we went up 1 and left 4. Or what most people will do first is rise negative 1 to here and then run positive 4 to there. It's the same line. Doesn't matter. Let's do it again. Rise negative 1, go 4 right there, erase this stray mark. Okay. Let's go from this point, go up 1, 4th, 1 over 4. Okay. So there is y equals negative 1/4 x minus 1. Okay. So now let's look at this particular equation to graph here. I want to do it the easiest way possible. All right. Now, it's very easy if it's given to me with y equals. It's also easy, like in question 1, when I have a positive y and I can just cancel, the first term by either adding or subtracting. But in this case, I've got a 4y. I can solve for y if I want to, but I have no reason to. I want to make this as easy a question as possible. So when you have the x and the y on the left and the constant on the right, that's called standard form. Okay, write it here. If it's in standard form, we call it ax plus by equals c. The x and the y are on the left, the constant's on the right. If it's in standard form, sometimes what is nice to do is the following. We could just find a couple of nice little points with a little xy chart. Okay, follow me. Okay, if I put, let's say 0 for y, that's an easy one, right? So if I substitute 0 for y, I got 4 times 0 is 0. And that means x plus 0 equals negative 4, right? X plus 4 times 0 equals negative 4. So the 4 times 0 cancels. I get x equals negative 4. Right? So I got the point negative 4, 0. Okay, so I'm going to erase this, keep it clean. So negative 4, 0 gives me a point. Well, look, it's amazing. That's going to be the solution, it looks like, unless they happen to be the exact same line. Ooh. So don't just get that point and say, oh, I'm done, negative 4, 0. That's my answer. Right? Let's find, that was the x-intercept, right? Because that's the x-axis. Let's find the y-intercept. Substitute 0 for x, see what happens. If I substitute 0 for x, what happens? We get this. Let me put my work down here. 0 plus 4y equals negative 4. Okay, so the 0 plus, I don't care about that. That's just 4y equals negative 4. I divide by 4. I get y equals negative 4 divided by 4 is negative 1. Negative 1. Yeehaw. Well, look at that second, look at that second point. If I connect those, look at that. It's the same line. The red and the blue are the same line. So if I had gone through and solve for y with this one, it would have come out to y equals -1/4 x minus 1, believe it or not. So these are just two different ways to write one line, which means that at every point, so we found two of them already, -4, 0, and 0, -1. But look, every single point on this graph, okay, that's actually on the graph, every single point on the line is a solution. So guess what? The solution, there are infinite solutions. There are infinite solutions. Okay, because this point's a solution, and this point's a solution, and this point's a solution, and this point's a solution. Every point, and that goes to infinity and negative infinity. So it's going left, it's going right. Every point is a solution. There are infinite solutions. Okay, so now we're going to do something kind of cool. We're going to use the graphing calculator. If you have a graphing calculator at home, great. If you don't, I highly recommend that you take your lovely little iPhone and you try to get this app. It's called Calculate 84. You can see in my window here. And once you download that, you basically have your calculator become this phone. Okay, the phone transforms into a TI-84 graphing calculator, which is really neat indeed. So I will use that in a second to help you kind of step through these steps. Okay, so using a graphing calculator to solve the system. Okay, so what did we just do? We graphed by hand and we found where they intersected. Well, we're going to do the same thing, but we're going to let the graphing calculator do it for us. Okay, so first thing you're going to do is you're going to hit the y equals button. Once you hit the y equals button, you're going to type your equations into the y1 and y2 lines. If there's anything else that's already there, go ahead and hit clear so that there's nothing anywhere in y1, y2, y3, y4, y5. Okay, make sure that no knucklehead went and put a bunch of gibberish into your calculator of the previous class if you're borrowing a calculator. All right, make sure that you have a nice clear set of y1s and y2s and everything else there. Okay, so you type your first equation into y1, y equals, say second equation into y2, y equals. Then if you remember Zoom 6 just makes it so that your x window goes from -10 to 10, and your y part of your window is from -10 to 10. Okay, so it's a pretty standard window. That's why it's called Zoom Standard. And once you've done that, if you can see the intersection on your screen, then you can get it very quickly and very easily. Okay. If you want to use the ALEX calculator, you follow the steps on ALEX. Okay, ALEX is probably a little simpler actually to use their calculator. However, if I give you these two equations, and they would be y equals -2x minus 5, and y equals 5x plus 6. Okay. If I give you those two equations and I say, here's a linear system, because there's two equations, and I say, give me a solution. Type those into your calculator. You can type the first one into y1 and the second one into y2. Okay, so there's your y1 and your y2. You type it in, and you see what you got. Okay. Now, the ALEX calculator just has buttons you can push that'll just give it to you with a couple of clicks. If you have a graphing calculator, TI-83, then let's see if we can walk you through that real quickly with my Calculate 84 app. Okay, so you can see my Calculate 84 app. All right, so I have taken the liberty of typing in y equals -2x minus 5 into y1, and y equals 5x plus 6 into y2. All right, so if I hit zoom, and then I go down to 6, or I just hit the number 6, then we get your standard window, -10 to 10, -10 to 10. Okay. So again, the first one, negative 2x minus 5. In my phone, that is the blue line, and then 5x plus 6 is the black line. Okay, so we want to see where that point is. Where is that point where they intersect? Okay, well, yeah, I can hit that button. That's more like the Alex. If you wanted to do it old school and you have a real like calculator or a calculator, you would have to do this. You would hit second, the blue button, and then trace, which is calculate. So second trace gives you this right here. Then you notice that number 5 says intersect. Okay, so either choose 5 and hit enter, or just hit the number 5. Okay. Now it'll ask you, first line, second line, or left bound, right bound. So I'm going left, I hit enter. I'm going with my right arrow, hit enter. Okay, so it tells me my intersection is this point right here. Negative 1.57143, comma, negative 1.85714. Right? Hopefully you see why this would be a question that the calculator would be better equipped for, just because it doesn't come out to a nice whole number. It doesn't come out to like a 0.25 or a 0.5. These are a little bit funkier decimals, right? So those are your options as far as either using Calculate 84, which is basically the same as the TI-84, which you can use in my classroom, or if you use the Alex calculator, you can just hit intersection, and then it'll give you the same information as you have right there. Okay. Okay, let's finish strong. Last page, writing a system of linear equations if they give you a graph, right? So you've done this before. You've done this in Algebra 1 with one line at a time. So let's go with this line right here. Okay, so we'll call this line 1. Right, we'll do it in blue. We'll put the equation right there for this one. Okay, all right. So y equals mx plus b. Y equals mx plus b. Step 1, what's the b? Step 2, what's the m? Step 3, write your answer. Okay, so it's going to be y equals, which they've already given you. That's nice. You're going to have an m, then you're going to have an x, then you're going to have your plus b. Okay, so step 1, what is the b? Okay, that's a negative 4. So b is negative 4. Done. Step 2, what's the m? Okay, start at either one of these points. I'll start at the one that I just circled, and I'm going to rise and run to get to the other point that's right on the grid that they've given us. So I'm going to rise 2. So rise, overrun, 2, 1, 2, 3, 4. 4. Now, this is a downward falling line, so I know my answer has to be negative. Okay, so it's a negative, and there was a rise of 2 and run of 4. Okay, so if you want to say it was a rise of negative 2 and a run of positive 4, that works as well. So keep your negative. 2 over 4, we always reduce our fractions. So we put it right there. So y equals negative 1/2 x minus 4. That's the equation. Okay, let's take green for our next one here. We'll call this one line 2. Okay, so for 2, right, same thing. It's going to be y equals something x plus something or minus something. Step 1, What's the b? What's the y-intercept? Well, here's the y-axis. The y-intercept is right here. That is a positive 6. So there's a plus 6 at the end of this equation. Second step, what's my m? Okay, I'm going to start at, I'll start at this point. Okay, I could start at this point and go to the other one. I could rise and run this way. Doesn't matter. It doesn't matter. As long as you start at one and go to the other. I know that this is falling to the right, so I know that my slope is negative. Okay, so if I do my rise over run, I know that I got a negative answer coming. Okay, so rise, I'm going to go from 6 down 12 units. Okay, that's 12. And then over to the right, 4 units. And I know that it's negative. Okay, if I had done it the other way, I would have gone positive 12 over negative 4. Either way, it's going to be a negative 3 over 1 or just a negative 3. That's it. I got my system of linear equations that reflects this graph right here. Okay, and if you want to double check it, you can take your calculator, type your equations in, look at it, and it should look like that question graph right there. Okay, home stretch, last question. Identifying solutions to a system. Okay, so remember, a solution to a system must work for all equations in the system. Okay, does it work for all the equations? In this case, there's only 2. If it works for both, it's a solution. Okay, if it works for one but not the other, it's not a solution. Okay, if it doesn't work for either one, it's not a solution. Okay, so let's look here. Negative 6, 0. Yes or no, is it a solution? Well, let's try it. Okay, let's go with the first equation here. So negative 6, 0. Okay, that means that 0 would be the y. Negative 6 would be the x. Okay, does this work? Well, this is negative 12 minus 8. Does that equal 0? Yeah, no. Not even close. Okay. Why don't I try the other line? Because I don't care. I could care less if it's on the other line or not. If it's not on both lines, it is not a solution. And this question just said, is it a solution? So let's go with our next question. This one right here. Let's take the first equation again. So we're going to use negative 5 for y. And we're going to use negative 1 for x. Let's see if this works. Okay, 2 times negative 1 is negative 2. Negative 2 minus 8 equals negative 5. Is that true or is that not true? No, not true. So once again, I don't even have to do the second equation. I know that it's not on the first equation, therefore it can't be on both. So it's not a solution. Okay, all right. We are 0 for 2 on this one. So let's try 9, 10. Okay, again, let's try the first equation, see if it works. So 9, 10. So we're going to substitute 10 for the y and 9 for the x. Okay, 10 equals 18 minus 8. It does equal 18 minus 8. So that means that this point works for line 1. Okay, wonderful. Now that just means we can check for line 2. If it works for line 2, it's a solution. If it doesn't work for line 2, it's not a solution. So here we go. 3 times x, so 3 times 9, minus 2 times y, and our y is 10. It's 10. Equals 7. Okay, 3 times 9 is 27, minus 2 times 10 is minus 20. Hey, 27 minus 20, it equals 7. Cool beans. So that is a yes. Okay, awesome. All right, the last one. We'll try 2, -4. Okay, now if you're thinking, hey, wait, this is the solution. I know that's the solution. There's no more solutions. Well, remember, we did have one where there were infinite solutions. So because we tried these guys and these weren't on the first one at all, that doesn't tell me that there's only one solution. These two equations might be the exact same equations. We haven't really looked into that yet. Okay, so instead of looking into that and doing the algebra, I'm just gonna test for 2, -4 in both of the equations. See what we get. So let's try the first one. So y equals, so -4 equals 2 times x minus 8. Okay, 2 times 2 is 4. 4 minus 8. 4 minus 8, that's -4. That one works. Okay, so we got to try this last one. 3x, so 3 times x, so 3 times 2, minus 2 times y, so 2 times -4, equals 7. All right, let's see. 3 times 2 is 6, minus 2 times -4 is plus 8. 6 plus 8 equals 7. Nope, it doesn't. So the last question is a nice one to look at because that was a point that was on the first line. It just was not a point that was on the second line. So therefore it's not a solution. Okay, I think we're done. Okay, day one's in the books. See ya.